On July 7, 2007, a lightning fire burnt about a third of the study area shown in hatch marks on the map. It burnt both monitoring sites TS1 and TS3, which allows us to look at effects of fire at both shallow and deep ends of the depth-to-water gradient. Results are best seen in photographs. Monitoring site TS1 is on the left and TS3 on the right. Groundwater at TS1 has been drawn down continuously since 1989, while TS3 has had 2 cycles of drawdown and recovery. We showed hydrographs for these sites in a previous slide. The top photos show the sites when they were newly established in 1988. The numbers between the photos are the grass-shrub ratios. In 1988, ratios for both sites were similar, as was total grass cover. The bottom photos show the same monitoring sites 19 years later, just before the fire in 2007. Shrubs have encroached at TS1, and there is virtually no living grass. The grass-shrub ratio has declined to less than 0.1. At TS3, grass cover is close to what it was in 1988, as is the grass-shrub ratio. The top photos show the monitoring sites about 2 weeks after the fire. The bottom photos show the sites a year after the fire. At TS1, noxious weeds such as Salsola species or tumbleweed and Bromus rubens, red brome, have started to invade, and there's very little native grass. At TS3, grass recovery is so robust it's hard to tell a fire occurred. The top photos are the originals from 1988. The bottom ones were taken this year, 2009, 21 years later. At TS1, the green in the bottom photo is almost entirely tumbleweed. TS1 has been subject to continuous groundwater drought since 1989, and it's a management disaster. At TS3, in the bottom photo, grass cover is higher than when the site was established. TS3 has been managed in compliance with the conceptual model of cycles of drawdown and recovery, or managed groundwater drought. The results of the unplanned experiments in groundwater management and response to fire are dramatic, but not surprising. The idea that continuous drawdowns diminish grass and foster shrub encroachment follows from the observations of Charles Lee in 1912, and people have known for thousands of years that fire can regenerate well-watered meadows. The case study is noteworthy not because the results are unexpected, but because it raises the question of why some areas are being managed in ways guaranteed to produce precisely the results the water agreement is intended to prevent. This question can be answered at many levels of detail, but the simplest answer is that a spatially consistent application of the biological model of cycles of drawdown and recovery would require Los Angeles to pump less water, thereby reducing flow down the aqueduct. This graph from Los Angeles' 2008 Owens Valley report shows annual pumping since 1970. You can see the spike in pumping during the late 1980s, which caused the enormous drawdowns in the study area and elsewhere. The average annual pumping since the mid-1980s, the baseline period for water agreement management, is about 93,000 acre-feet. The problem is that the U.S. Geological Survey estimates that long-term average pumping should not exceed 70,000 acre-feet a year if sufficient water is to be provided to maintain baseline vegetation conditions. That's an annual excess of about 23,000 acre-feet, and it's worth over $18 million a year at today's prices. How can this excessive pumping continue when the water agreement calls for sustainable management? Unfortunately, there are many ways, and in the remainder of this presentation we will show a few examples. The first is the use of brute political and legal force. We described the drought recovery policy in a previous slide as an insurance policy guaranteeing recovery from overpumping during the climatic drought of the late 1980s. In 2000, Los Angeles hired consultants to evaluate this policy. The consultants concluded that criteria for terminating the policy had been met. They reached this conclusion by decoupling management from biology. Although the policy's explicit goal is recovery of soil moisture in vegetation rooting zones, the consultants decided it could be terminated upon recovery of just 80% of the groundwater drawdown, regardless of conditions in vegetation rooting zones. Los Angeles then unilaterally terminated the policy over Inyo County's strong objections. Los Angeles also awarded the consultants a multi-year contract worth over $20 million. Another example is the use of mitigation projects to shield exports. When Los Angeles increased its pumping in 1970 to help fill the enlarged capacity of its aqueduct, it dried up Black Rock Spring. Water from the spring, about 8,100 acre-feet a year, formerly flowed through Black Rock Fish Hatchery, then directly into the aqueduct. To mitigate the drying of the spring, between 12 and 13,000 acre-feet of water a year are pumped through the hatchery. Simply reducing pumping to 8,100 acre-feet a year, the amount of the former spring flow, would provide the hatchery as much water as it was built to use, and also allow water table recovery under the case study area. Reducing pumping for the hatchery, however, would also reduce flow into the aqueduct. Although Antonio Villaraigosa, the current mayor of Los Angeles, and his appointees have repeatedly claimed their absolute commitment to their environmental protection obligations in Owens Valley, their predecessors made no such commitments. In this example, then chairman of the LA Board of Water and Power Commissioners Dominic Rubalcava made increased water exports a condition of renewing the lease for the city of Bishop Airport. Unfortunately, nothing will prevent future water and power commissioners from reverting to this kind of behavior. By 2005, Inyo supervisors had a backlog of a dozen water management disputes with Los Angeles. Most of the disputed activities had led to increased flows down the aqueduct. Most of the disputes remain unresolved this year, 2009. Acquiescence is easier than resistance and doesn't cost the county money. Sustainable management is eroding away. The water agreement was undermined from its inception by enormous drawdowns caused by pumping during the unmanaged climatic drought of the late 1980s. Full recovery has yet to occur. Our case study shows the agreement's conceptual model of cycles of drawdown and recovery, or managed groundwater drought, can meet the agreement's goals, but it hasn't been consistently applied. The problem is not a lack of ecological understanding, but a lack of political will to face the inconvenient truth that sustainable management will reduce flows down the aqueduct. People hoped the water agreement would end years of hostility between Inyo and Los Angeles. Its implementation instead has turned into a lesson in the difficulty of attaining environmental justice in the presence of huge disparities in financial and political power. We would like to acknowledge Andrew Elmore of the University of Maryland, John F. Mustard of Brown University, the Inyo County Water Department, the University of California White Mountain Research Station, the Big Pine Paiute Tribe of the Owens Valley, the Bristlecone Chapter of the California Native Plant Society, and the Inyo Register.